Bismillahirrahmanirrahim. Dear students, my name is Muhammad Zubair Awan, and today this is our eighth lecture of artificial intelligence. If you do have any type of question or any type of confusion in our last lecture, you can email me or you can WhatsApp me. I will definitely try to reply you. Before wasting time, we will start our lecture. So today lecture is very interesting. That is knowledge representation. If you look at this picture, you will see uh, two type of this is tag the games over on a brain. So there are two animals in this picture. So what you say about this picture? What this picture says, what this picture is saying, and what this picture is saying. These all pictures are giving us different knowledge. So this is known as knowledge representation. So representing your information in your own way is known as knowledge representation. When we use search to solve a problem, we must capture the knowledge needed to formalize the problem. Whenever we uh, search for a problem, we must have to have the knowledge that we have to solve the problem. If we do not have the knowledge about the problem, we cannot solve the problem. Apply a search technique to solve the problem, then after the knowledge gathering regarding the problem, we apply a technique to solve the problem, and at the end execute the problem. So these are the three steps involved in knowledge representation and also in solving a problem. First, capture the knowledge, then apply the technique, and then execute the problem solution. So dear students, here is the first step is what is the role of knowledge representation. It is also known as KR, role of knowledge representation. Formally, the intended role of knowledge representation in the artificial intelligence is to reduce problems of intelligent action to such problem. A good description developed within the conventions of a good knowledge representation is an open door to problem solving. And also, a bad description using a bad representation is a brick wall preventing problem solving. That means these two paragraph means that if you have a good knowledge representation, you can solve a problem very easily. And if you do not have the knowledge representation, good knowledge representation, you cannot solve the problem accurately. Let's take an example that if you are solving a mathematical problem and you are writing on your notebook randomly, like you are not considering the lines and you are randomly writing all the data from one line to another and three to four. So there will come a point when when you are when this question will become complex enough that you would be unable to solve any you would be unable to solve this problem that you have solved on your copies. So this is the actually the role of knowledge representation. Before any problem, you have to represent the knowledge, or you have to represent the I must say module, or the description, or the rules, or anything that is involving in that particular problem solution. You must have to the basic knowledge representation. We previously talked about applications of search, but not about methods of formalizing the problem. So, right, we have in the last lecture we have discussed about the searches and the algorithms and the techniques. But for those to solve those techniques, we must have a formalizing way to solve the problem. Now we look at extended capabilities to general local reasoning. Here is one knowledge representation, that is logical expression. Like one way of expressing the knowledge is your logical expressions. So what are these logical expressions? Let's talk more. A knowledge-based agent must be able to represent states, actions, etc. In the last lecture, we have discussed about states and actions, incorporate new percepts, update internal representation of the world. The world means the area in which we are solving the problem, deduce hidden properties about the world, deduce appropriate actions. But we will describe properties of languages to use for logical reasoning first. Second, what we will do describe techniques for deducing new information from current information. And the third thing that we will do is apply search to deduce specifically needed information. So the Wumpus world environment, the environment means in which you are playing the game. This is a Wumpus world environment. As you can see, there are boxes and there are some phases down. Here is the Wumpus world agent description, like performance measure, gold plus 1000, death minus 1000, minus 1 per step, minus 10 for using arrow. So this is a game that you can also download from your mobile phone and you can play. What is the environment of this game? Scare adjacent to Wimpus are smelly. If there is a Wumpus, all the scares around the Wumpus would be smelly. Scares adjacent to pit are breezy. Glitter if gold is in same square. Shooting kills Wumpus if agent facing it. Shooting uses up only arrow. Grabbing picks up gold if in same square. Releasing drops gold in same square. So this is the total environment, and this is a controlled environment, and this is fully observable environment, as we have discussed in our last lecture. That what is fully observable? Fully observable environment is that environment that is that you have predefined rules for any game or any problem. So what would be different actuators? Actuator means what the Wumpus world can do. It can turn left, it can turn right, it can go forward, it can grab, it can release, and it can shoot. So sensors are breeze, glitter, smell, bump, and scream. So these are different types of sensor. These are actuators that we have discussed in lecture number 3 and 4. And this is environment and this is performance measure. So dear students, here we have 6 questions that whether the Wumpus world environment is observable, it is partially observable. Whether it is deterministic, Yes, it is deterministic. Whether it is episodic, it is sequential. Whether it is static, yes, for now, Wumpus and pits do not move. It is also static. Discrete, yes, we have uh, predefined steps to go forward and backward. So this is discrete. Single agent, no, we have multi agents. We have many other things along with the Wumpus. And finally, we have the simple run for this game. You have to consider this line perception. Perception means what this agent is perceiving from the nearby boxes. What deduce? It deduce means agent alive, so 1 1 okay. That means we have to move forward. No breeze, so 1 1 1 2 1 2 and 2 1 is okay. So on this in this state the agent is alive, so 1 1 is okay. We have to move forward. So in our next run we will first action we will turn right and go forward. So in the last picture we were here and in next picture we are here. But when we move on here, we have perception that there is a breeze. Breeze means this is there is any problem near the in near box. So deduce pit in 2 2. Here is pit. We cannot move there. Or in 3 1. There can be there is a perception that in the next box there could be a pit. So this is not a safe place to sit here. So we will move backward to 1 1 here, then to 1 2, because when we move here we have we receive a perception that here 2 2 or 3 1 have a breeze. So we will move backward and then go to 1 2. So stench, here is stench, here is nothing. Wumpus in 1 3. So Wumpus is 1 3. No pit in 2 2. 2 2 is okay. Pit in 3 1. Pit in 3 1. So 8's also okay. So what would be our next move? Move to 2 2. This one is safe place because the P is here and Wumpus is 1 3. So in between these two, this is the safe place. So we'll move to 2 2 and move to 2 2, turn, go forward, ignore perception, move to 2 3. Then we have move on to 2 3, but here we have perceived that we have a pit in the 2 4 and 3 3. So gold in 2 3, gold is in 2 and 3. So here is the gold and we have picked ignore perception from now, move 2 3, turn left, go forward, move to 1 1. Again we have moved to 1 1 through OK location. We have this one is OK location. This is the OK location. So we will come back and how to present fact belief there is a pit in 2 3 or in 3 1. So we are here in this scene, and this is how to make inferences. No breeze in 1 2, so pit in 3 1. So all this we have done in our this example. This is actually the problem. This was the actually problem, and we were actually solving the problem over here. So This is a simple run of Wumpus world. Here is another very important topic, that is representation, reasoning, and logic. Sentence, individual piece of knowledge, very easy. English sentence forms one piece of knowledge in English language. Statement in C forms one piece of knowledge in C programming language. Yeah, this is statement. Syntax forms used to represent sentence. So, what is syntax in knowledge representation? It is used to represent sentences. Syntax of C indicates legal combination of symbols like A is equal to 2 plus 3 is legal, but A is equal to plus 2, 3 is not legal. So, this is the syntax. We must have to consider the syntax of any language or any formula. Syntax alone does not indicate meaning. So it is very important that syntax is not the all thing that we will see all the meanings or all the perception of any problem. So there must be any other thing, and that is semantic mapping from sentences to fact. In the world, we in the real world we do not have all the English or all the we do not have, most of the time we do not have any kind of suitable word or suitable language for any particular problem. So we say that about anything, that this is the main idea why we use semantics. Semantics means that the second, I must say, the second meaning of that sentence is semantic. They define the truth of this tense possible word, add the value to a tree, store them in memory location, indicate by variable. In the language semantics, this is the sentence x plus 2 is greater than or equal to y is a sentence. So x2 plus y is greater is not a sentence. This is not making any sense. And here we have x plus 2 is greater than is equal to y is true in all words where the number x plus 2 is so less than the number y. So these are the some are the sentences and some are not the sentences. So x plus 2 is greater than y is true in world where x is equal to 7 and y is equal to 1. X plus 2 is greater than y is false in world where x is equal to 0 and y is equal to 6. So the thing that is very important to remember in this slide is what is sentence, what is knowledge, syntax, and semantic, and what are in the in arithmetic. So what are models? Which are formally structured word with respect to which truth can be evaluated. There are possible words. M is a model of sentence if it is true in M. M is set of all models. Like model is anything that is structured or with respect to which truth can be evaluated. Like if we are making an experiment, we will first of all make a model. So dear students, our next topic is use two different ways generate new sentences that are entailed by KB. So this is inference actually. What is inference? Determine whether or not sentence is entailed by KB. So a sound inference produce generates only entailed sentences. What it mean? Modus ponens is sound A. A implies B divided by B. So this is the actual modal ponens sound. What it's not, like it's B. A implies B divided by A. So what is the definition? A complete inference produce can generate all entailed sentences from the knowledge base. This is the example of inference. The meaning of a sentence is mapping into the world a model. Okay. The meaning is an interpretation, that is Lisp code. A sentence is valid, necessary true if true under all possible interpretations. So these are the different mathematical notations of inference. Like today is Monday, 2 plus 3 is equal to 5. And the last sentence is satisfiable, meaning there at least one interpretation that makes the statement true. The previous statement is unsatisfiable. Here is another topic of your course outline, that is logic. Logics are formal languages for representing information such that conclusion can be drawn. Logic are characterized by primitives, commitments, and languages, prepositional logic, first order logic, temporal logic, temporal logic, portability theory, and physiologic. So these are different languages and ontological commitments, facts, objects, relations, facts, subjects, relations, facts, and degree of truth. And the next is the epistemological commitments, true, false, unknown, true, false, unknown. So these are the different types of logics. So what is prepositional logic? Simple logic, symbols represent entire facts. Boolean connectives, prepositions like true, false, first order logic. What is first order logic? Extend propositional logic to include variables, quantifiers, functions, and objects. If we uh, put uh, uh, these variables, quantifiers, functions, and objects into the prepositional logic, that it will become first order logic. What are prepositional logic? Q, P, and Q, etc. are sentences. The true false value of prepositions and combinations of preposition can be calculated by using the truth table. So if P and S are sentences, then so are these are the prepositional logic. P implies Q, P do not implies Q, and interpretation consists of an assignment of truth value of all prepositional symbols, and interpretation is a Logins word for word is often called a possible word. So these are the prepositional logics that you can see in this slide. This is the truth table for the prepositional logic. A logic is monotonic as long as entailed sentences are preserved as more knowledge is added. So this is the truth table. PQ, P implies Q, P and Q false, and P implies Q. These are all true. So here are some few knowledge about Forbes syntax. Constant symbols, capitalize functions with no arguments. Predicates can make arguments true, false. Interpretation maps to relationship or property. Function can take argument. So these are constant, predicates, and functions. So dear students, we have discussed here the logics. We have also discussed inference and the models. We have also briefly discussed about Wumpus model, and then the topic knowledge representation, reasoning, and logic. And here we had discussed about knowledge based agent, and the very important, the main topic that we have covered today is knowledge representation. So dear student, this is all from this lecture. I hope you have understood all the concept that we have revised. One thing I want to share with you that if you do have any type of query, or if you do have any type of problem regarding the knowledge, you can simply contact me on my WhatsApp number, and you can also email me. Uh, Plus, for extra knowledge, I will suggest that you visit the Google and also search more data about these. So, in our next lecture, I will explain one of your pending assignment, and I will in next lecture I will upload, and in after that you will email me your assignment on this email within the due date. So I would like that I need your response about this subject. You should, or I appreciate if you will message me or inbox me regarding the feedback of this subject. Uh, Dear student, this is all from lecture number 8 of artificial intelligence, and take care, and Allah Hafiz.